Alrighty, welcome everyone to day 24 of Advent Decode. This means that after today we only have one more day left. So this is the last 2 days we are on. 25 seconds left. I'm very happy with how this year's gone. I've been enjoying this year very much. Thank you to Eric for all the work he's done. He stopped by the stream the other day. He was chatting a bit, but again, thank you, man, for all you've done. Very much appreciated. This year has been fantastic. Definitely, this is my second year doing it. I did much better than last year for sure. But at any rate, 3 seconds to the puzzle for today. Let's get into it. Raph makes it to the tropical island. Turns out the small crab was an excellent navigator. You made your way to the resorts. As you enter the lobby, you discover a small problem. The floor is being renovated. Can't even reach the check-in desk until they finish installing a new tile floor. The tiles are all hexagonal. They need to be arranged in a hex grid with a very specific color pattern. Not in the mood to wait, you offer to help and figure out the pattern. The tiles are all white on one side and black on the other. They start with the white side facing up. The lobby is large enough to fit whatever pattern might need to appear there. The number of the renovation crew gives you a list of tiles that need to be flipped over. Puzzle inputs. Each line of the list identifies a single tile that needs to be flipped by given a series of steps starting from the reference tile in your very center room. Every line is okay. Because the tiles are hexagonal, every tile has 6 neighbors: east, southeast, southwest, west, northwest, and northeast. These directions are given in your list respectively. A tile is identified by a series of these directions with no delimiters. For example, east identifies the tile you land on if you start at the reference tile, then gives you in the example above, 10 tiles are flipped once to black and 5 more are flipped twice to black and then back to white. After all of these instructions have been followed, a total of 10 tiles are black. Go through the renovation crew's list and determine which tiles they need to flip after all the instructions have been followed. How many tiles are left with the black side up? Hexagonal. I've never done hexagonal before. So example of 10 tiles are flipped once to black and 5 more are flipped twice to black, then back to white. So each time a tile is identified, it flips from white to black or from black to white. Tiles must be flipped more than once. So they're all white. They start with the white side facing up. So is this just literally... Okay, so there's just no delimiters, but it doesn't matter. The new lines don't matter, right? I don't know why that popped up. Well, oh, we flip wherever we end up. Okay. So this comes back. So we need like some sort of hexagonal grid here. Okay, I've been thinking about this for a while. I was just trying to figure out hexagon, but my issue I kept coming back with is if you were to go from a point, go around and then come back to that point, how would you know you've reached that point again? With that tile grid system I was about to build, that's like a linked list essentially. I couldn't figure out how I would do that. Maybe I would need to, maybe I wouldn't, but I didn't want to go down that path if I couldn't figure out how to solve that. So what we're going to do is we're going to use a grid. We're going to do we're going to need a grid. We're gonna actually, well, let's bring back this. But instead, we're going to have this. We're going to have a private integer, or a private int x, private. I'm doing private. It should be public. We're just going to do an x and y. And so the way you can do it this way is you can just offset rows, basically, for these, and that's how you can do this. So we're just going to do a list of hexagon. Actually, let me just do a public static class vec2. This will make my life easier for these, because now I can have these here. I can do public position, and then I can override this for the hash code. Cool, I can override those. And what we can do here is we can do actually a map of the vector2i and then the hexagon. equals new hash map. Okay, and so then there's tiles. We're gonna go for string s in input strings. Do that. Okay. And then what we're gonna do is we're going to have to dump tiles. Put new. Does this actually even need? We might have not even need this. We might be able to just get away with a boolean here. Let's just use that. We don't even need this hex now. So then we can just do new. This is going to be a constructor. Back to I don't know why I call it vec, whatever. Okay. So there's that. So now we're just going to do int x, int y, this dot x equals x, this dot y equals y. Okay. And so now it's going to be a new vec2i 0 0 and true because it is white. Okay. So I'm going to go through these. So now we need to then we need to break these up. So we're going to have strings. So we're going to do while, we're going to hold an index. So int I equals 0. While I is less than s dot length. We need a new vector here. So this is a reference. So we don't, I'm guessing the reference point we don't include. So I'm guessing we don't flip over the reference. Okay. So let's do vec2i current equals this. And then we're gonna set current to here. All right, so now we have our current vector. And now we need to essentially hop. So what we're going to do is we're going to do if s dot char at I equals what is this? It's going to be an E or a W. If it equals E, we'll do this way. So it's going to be then current. We should just add an add public public void add x int y this dot x plus equals x this dot y plus equals y. So then we can do current dot add. We're going east. We're just going to add 1 to the x. This one's easy. We don't need to do anything with this. So, okay, so we're gonna add, so east is easy, east is easy, add 1. West as well is easy, we just subtract 1. Else, if it is not, we need to then, so else if it's gonna start with, I guess, north, we're gonna need to then do I plus plus. And do another check here on those. So yeah, northeast, northwest, right? Northeast, northwest, okay. So northeast, after all this, we're gonna do Apple Plus. So northeast is going to be easy because it's again just add 1, but we need to check here is we need to do an if current dot, I have a reference here of like a hexagonal grid, so I'm looking at if we have an odd in our no if the y is odd, so if current dot y %2 equals 1, we need to then add 1 to the y. Actually, we should be doing -1. North can be subtracting, right? So We're at 1, 1. We go up. We subtract 1 from the y. Good. And then we just need to go east or west. Okay. Which is handled right here. Good. So that is that done. Otherwise, we got to deal with now south, which is the same thing, but just going up in that. And there we go. Okay. Sweet. So that's going to handle the movement, and then what we need to do here is we just need to then do a check. We need to check for if tiles contains key, current, if it does, tiles. Is there an update? We can replace current with the opposite of tiles get current. Otherwise, if we've already visited this location, tiles put current and false because it starts at that. So it gets flipped over. Okay. Sweet. So this should, in theory, work. And then all we need to do is at the very end, we need to go through and count them up. Which tiles need to flip? After all the instructions have been followed, how many tiles are left with the black side up? Okay. So then we just need to, at the very end of this, do public, system out print line. We need to do a for loop. So for vector 2, vec and tiles. Actually, we could just do tiles values, couldn't we? Do boolean and then white side up, and we can do an int black side up count equals 0, and we just do a check here if it is not white side up. We do this plus good, output that, run that. Let's make sure this runs in a good enough. Cool, I ran pretty quickly. Let's take the example inputs and make sure this works. We should get 10. 29. Ah, it's in there twice. Okay. How is hash code not working? Because it's the same one over and over and over again. Oh, I think I see what's happening. Oh, I know what's happening. I'm just dumb is what's happening. What's happening is I'm just dumb. I see what's happening. We need to do then. That goes away. I see what's happening. Okay. So we do current that. Okay. Okay. Please now work. We get 10, and then we get just 1. So no matter what... Ah. Okay, so this needs removed. So if we are going east, this is where it's messing up. It's here. So we only update the X if it is odd. If it's even, the X stays the same. Or opposite way, sorry. If this is even, we then do it. Otherwise, if this is odd, we do it that. Okay. Okay, I think I figured this out now. There. There. Remove that. So now give me, like, what is it? Does it give me 10? Is it? Might be only the last one. So it might be whatever we land on. So instead of this, you want to do it right outside here. There we go. Okay. Finally. Now let's put our input in, right? We get 10. Let's put our input in now. Okay, and then we can call lap on this instead. Be done, be right. Give me a number, 245. Submit this. It's not right. Oh. Oh, because we're not still not storing this. Int or Boolean odd. So we want and odd and not. I think that's why this is failing, because I'm already updating current Y. This is odd. This is not odd. Please, still give me 10. And now I'm getting 14. Going north. Going north. Our Y is even. On an even. West does change. There we go. Okay, I don't know what my logic was. Okay, now let's put our code in here. And now we're gonna get a new number. We're at 317. There we go, okay. Wow, that took me way too long to figure out the logic here of when the X's flip. Holy, okay. That was bad. Part 2. The tile floor in the lobby is meant to be a living art exhibit. Every day the tiles are flipped according to the following rules. Any black tile will 0 or more than 2 black tiles immediately adjacent to it flip to white. What? The tile floor in the lobby is meant to be a living art exhibit. Every day the tiles are all flipped according to the following rules. Any black tile with 0 or more than 2 black tiles immediately adjacent to it is flipped to white. Any white tile with exactly 2 black tiles immediately adjacent to it is flipped to black. Tiles immediately adjacent means the 6 directly touching K. The rules are applied simultaneously to every tile. Put another way, it's first determined which tile needs to be flipped, then they are all flipped at the same time. 100 times. So after we do the inputs, we need to then go about flipping them. So we need to do for int I equals 0 while I is less than what? 100 days, while less than 100, I plus plus. So now we need to go through all of these, and we need to get the 6 immediately adjacent to it. So we just need to count so we just need to get all of the tiles adjacent to this. So we can do vector 2i east is going to be equal to vector 2i. I guess we just do we need to go around it in every direction. So we need to do east, west, northeast, northwest. So what if I break this out? If I break this out into some methods, it's gonna be public vector2i, no, public void move vec vector2i vec, and I guess we could just return. We could return the int, so we also get int I. Oh, well, we need to know. Okay, wait. No, we're going to move it string. Move it this much, so string s. Okay, so that'll do this. We call now move vec here. So I see string sub. So we give this sub, and we're gonna give it current. But all we need to do check here is we just need to do a check with this. If it's that, sub plus equals, so that is sub plus equals again. And this here. So we're breaking this out, we're moving this slightly. I guess we can just do it either or. Because it's, yeah, okay. I'll move vec. Now this all goes away. Cool, so now this should give us the same answer. What's going wrong here? I don't need to return anything. Void. No I. Oh, yes, I. Right. So we should still get 317? Sweet, still get 317. Good. So now that we have a move, we just need to do. You can make a little list here. We can do a list string of dirs equals new. Actually, let's do arrays or collections. No, it's raise. Oh, raise the as list. Why? Okay, I don't know why I was so confused. As list, then we just give it east, west, east. Wow. Okay, I can't type. Wow, I cannot really. I'm screwing. Okay, east, west, northwest, northeast, southeast, southwest. Okay, so we're going to go through everyone. We can do then a vector2i copy. We need to override clone. New vector xy. Okay. So now we can call compy is going to be equal to vector to I, clone, and then we just need to go through every dir and directions, dir and dirs, and now we can just call copy. Actually, no, we do this in here. Copy there. We're gonna go copy. We're gonna do move. Is it move vector? Copy in the direction, and then we just need to do a check if tiles contains key. We need to do this. Tiles copy. Is there a tiles like copy on this clone? Can I do a new hash map? Can I give it tiles? Can't. Okay, so now we have tiles copy is gonna be equal to that. So we just need to do is we need to check that, and if it contains the key, we need to have an int a black count. So if it contains the key, we're gonna do black, or if it contains copy and tiles get copy is false, then we do a black, we update black here. Okay. Any black tile is 0 or more than with 0 or more than 2 black tiles immediately adjacent to it flip to white. So it's only if there's a 1. Okay. So we do a check here. If tiles get vector to I. So if it's white, what we need to do is if there is 2, if it's white and black is 2, right? And it's flipped to black, so then we do tiles replace vector. No, not tiles replace. We do tiles copy replace vector to I with true. I guess we can just do a put. We don't even need this to be anything. We can just do a put there. Otherwise, it is tiles get to I. No, we can let's leave it as tiles. Let's leave it as tiles. No, what it was fine. Tiles. And then we use the other check is an else if it is a black tile, then we need it to be 0, so black equals 0, or black is greater than 2, greater than equal to 2. It becomes white, so we set that to true. Sorry, this is false. Okay, I think, hopefully. And then at the very end, we do tiles equals tiles copy. Okay, and then what we do at the very end, and then we do the same exact thing. Please give me a good answer. 2. There's no way it's 2. I'll say. There's no way it's 2. So given the example input, we get 0. Nice. Okay, so there's something wrong with my code, obviously. So 0 more than, we go back to white. And any white tile with exactly 2 black tiles immediately adjacent to it is flipped to black. Okay, let's give this a shot. We get 10 and then 8. We're not doing all of the tiles. We're only doing the ones that we hit. This is a cheap way to just generate a large area. That should be large enough to hold this. And we can then just do tile, compute if absent, new, vector 2i, x, y. Oops. Oh, put if absent. Okay, there we go. So now tiles should be good. So now if we run this again, we should get much higher number. Much higher number. That'll probably take a while to run. But hey, we get 2208, which is good to me. So now let's put our input in. See how long this takes. Hopefully not too long. Hey, 3804. Hey, we got it. Cool. Cheap way to do it, but that works. All right, so let's see if I can explain the solution here. So for today's problem, we are given a hexagonal grid with a kind of a map of how we walk on that grid and whatever tile we end up on that path. So we given a path here. Whatever tile we end up on that path, we then flip it from white to black. So we flip the sides of it from white tile to black tile, or if it's a black tile to white tile, so on and so forth. So what we do is we hold a hash map of all our tiles. Our tiles are a position, so an X, Y, and you can think of the grid system for this as a regular square grid, but every row is then shifted. I can just show you this here. This is what I was using as reference. So I was using this one here. So every row is shifted over. So all odd rows are shifted to the right. Even rows are normal. Odd rows shift to the right. Even rows normal. So basically, you can think of this as a square grid if, as you can see here, the highlighted bits column and then row. So you can think of that there. That's how we're using this normal grid as a hexagonal grid. So what we do is we're going to go through each line, or we're going to go through each line of inputs, and we're going to parse out character by character what action we need to do. If it's an E or an W, it's just done there. It's east or west. That's very simple. If it's east or west, very simple. We just add 1 or subtract 1 of the X. Done there. The hard part is if we're going north or south. If we're going north, we have to check that our current Y is even. If it is even and we are going to the west, we need to then decrement our X. But if our direction is north and our current Y is odd and we're going to the east, we need to then increase our X. So it's handling these cases where we're going to which one we're going. So if we're an even and we go south west, we need to remember that we need to decrement our X because we're changing our X, our X column here, or our X position, I guess. So that's the only hard part, is just figuring out what current hex we're at, and then if we're at even or odd, and depending on if our Y coordinate is even or odd, changing our X accordingly or not changing it accordingly is the only really hard part here. So that's what this code does. But beyond that, that's all we do for part 1. If you just go through all those, remove them, and then when we finally hit the end of the line that we've parsed the entire line, we just simply take tiles. If the tiles has our current location or has our current vector, we update it to be the flip of it. If it doesn't have it, we set it to false because everything tile starts as white. So of course we've landed on this tile, so we just put falsing, so we have made it black. And then we count all the black ones, and that's our part 1. Part 2, I cheat the system and I just make a 200 by 200 grid. Actually, it's 201 by 200. No, 200 by 200 grid. We fill it out. That way everything is white except for what was already in tiles. And then we just go through and do some checking on if the tiles are black around it and how many. Depending on how many black are around it, we then change the tile to be white or black each day. Do this for 100 steps, and then again count them all up, and we're good. So that was probably a terrible explanation, I'm sorry. But anyways, that is day 24, complete, done. Hopefully you guys enjoyed. I'll see you guys next time. Peace out.